Good morning, also from my side. Very happy that you're all here, found the way to us, and come from all around Europe. I hope not all around the planet, but all around Europe. I will kick off the first keynote together, freshly delivered from the Google I/O Connect with Abdel, and talking a little about Kubernetes, because it's actually the 10th year, the 10th birthday of Kubernetes. So if someone believes that Kubernetes is a super nice, fancy technology, it is, but it's not new anymore. It's a little bit old and has matured and has grown a very, very large ecosystem. And that's what we are going to talk about today, and also talk about what's the future of Kubernetes. Where does it go? What we do see at the moment. And maybe we try to make a look into the glass bulb and try to understand what could be the next big thing in all this Kubernetes echo space, universe, and so on. Give us shortly a sec until our slides are presenting. It's practically the dark mode.
Yes. Well, hold on a second. Much better.
Perfect.
All right.
Welcome, Abdel.
Thank you. Hi, everyone. How are you feeling today? No. OK. We need more energy. How are you feeling today? Woohoo! Good. All right. Well, thank you for having me. This is my second time at KCD Munich. Last year, I had just a talk. This time, they asked me to do a keynote. So hopefully, I'm not going to forget my talk. Some of you might recognize me by, this happens a lot when I go to Kubernetes events. Some people recognize my voice, but they don't recognize my face. I am one of the co-hosts of the Kubernetes podcast. Anybody here listens to the Kubernetes podcast? Few people. All right. I'm going to give you 2 minutes to sign up. No, I'm just kidding. So let's talk about this. I'm going to start my talk with a very strong statement. And you might agree or disagree with me, and I'm happy to discuss this later. By the way, I just have to do the keynote and leave. So if you disagree, you might not find, I'm just kidding, you might not find me at the event. But basically, in our field, we are not building anything new. The last thing that was new in the tech industry that we built was the tensor architecture for machine learning. We are only doing abstraction layers. We're only making things easier. And we have always been doing this for the last 35 years. And I'm going to explain to you why. 10 years ago, Joe Beda pushed the first Git commit that released Kubernetes to the world, June 6th, 2014. That was the first time Kubernetes became a thing. And people started talking about it, using it, and even using it in production. I cannot believe that 10 years later, I still meet people in places where they actually don't know how to pronounce Kubernetes. Any French people in the room? No? OK. So French people is Kubernetes most of the time. I mean, it's funny because it's a Greek word, so we don't expect people to know how to pronounce it. But it's just interesting that it's still not anchored in people's brain. Actually, it's even worse because still a lot of people don't know how to pronounce Linux, right? And a lot of people say Linux, which is not the right pronunciation. Anyway, like any open source project, Kubernetes has parents, people who have been there, who babysat the code, wrote the code, tested it, made sure it works. The common thing across the parents of almost every popular open source project is that they are people that started with the idea of something is too complex. We need to make it simple. So let's build an abstraction layer. And this is not actually new to Kubernetes. 25 years ago, somebody by the name of Linus Torvalds sent this email in which he mentioned something around the lines of like, I wrote a thing. I don't know if it's going to be a thing. People try it, please, right? Completely ignoring the fact that a couple of years later and up to today, it's the biggest, largest operating system in the world. Same thing happened in 2013 when Solomon Hykes went to EuroPython in the US, I think it was San Jose, and released Docker to the world. And in the process of demoing it, making a very, very obvious typo mistake, right? Again, same idea. Hey, people, containers is a thing that exists. I just made them simple. Here is my thing. It's called Docker. And you know, the rest is history. Going back to my initial statement about we're not building anything new. We're just making things simple. We're just building abstraction layers. Docker didn't really make anything new. Docker built on top of existing primitives in the Linux kernel to make containers easier. Like everything that Docker relied on already existed. It was just things that only few people knew how to actually use, because you needed to have a deep understanding of how the Linux kernel works, how C groups, network namespaces, etc., etc. Maybe the only piece of technology that Docker also leveraged, that maybe some of you, and this is how I know who is old in the audience, is chroot. Have anybody used chroot before? All right, so good. I am in the camp of old people. So again, building abstraction layers. We're just making things easier. The idea of abstraction layers is that you take something which is complex, you hide the complexity, you expose only the parts that people need to care about, and you make the rest easy, right? And in the process, and Max is going to touch on this actually later, in the process of trying to make things easy, we get to a point where we make them complicated, and then we just repeat that cycle all over the place, right? And as I said, this is not new. We've been doing this for a while. Virtualization is a great example of this. You know, we were doing everything in one server. Then we were like, too complex, let's do virtualization. Well, actually, virtualization was not really making things more easy. It was just being able to use more resources, being able to cramp more applications on the same physical server. So we created virtualization. And then we got to the point where it's like, too complex, let's just create containers, right? And this continues happening. I'm going to talk about another example of what's happening even now, today. What really containers did is that it fixed the problem of it worked in my machine, right? It's just, instead of having to ship a piece of software, which is an artifact, a binary, or having to ship an entire virtual machine, for those of you who have used Vagrant before, you know what I'm talking about. Now you ship a container. You build it, you put your code, configuration, dependencies inside the same thing called a container image, and then you ship the container image, and wherever there is a container engine, that container image will run, as long as it's built according to the OCI, the Open Container Initiative, which is the standards that all container platforms build towards, right? And we love it. Developers love containers because it allows you to do two things that are the two things that developers care about the most. Be lazy and shipping code. Be lazy because you can actually build on top of existing stuff. With containers, you can just pull an existing container and push your code inside. You don't have to do from scratch. And then just ship code, right? You literally push your container and then go, OK, boss, did my work. Not my problem anymore, right? Microservices existed way before containers existed, but containers kind of catapulted microservices even more, made them even more prominent. People started doing microservices quite a lot. People started releasing code more because it takes a few seconds to restart a container. So once you have a new version, restarts and it just works. And that's because everybody loves containers. Everybody wants to do microservices. I'm going to pause here because I want people to reflect on the fact that everybody wants to do microservices, even if microservices doesn't make sense all the time. Right? We agree? Nod your head. You don't have to raise your hand if your boss is around. OK, good. And then everybody just wants to release more code. That's actually what developers care about. So with whatever reason this is broken. Oh, OK, now it works. OK. So with this idea, with this background of making things simpler, abstracting, hiding complexity, that's what Kubernetes did. It just was released with the idea of people does distributed system, people do microservices. Microservices are complicated using automation tools like Ansible, Chef, Puppet, etc. So let's just make this tool that will run on top of a distributed system, give us a single API, so we can talk to that API and just deploy our applications. That's the philosophy of Kubernetes. That's the initial idea. And that came from internally inside of Google, people realizing that we had the same problem 20 years ago, and we built Borg to solve this problem, right? One of my favorite ways of describing Kubernetes, when people ask me, not the silly question of describe Kubernetes to a 5 years old, because that's a different way of explaining it, but explaining Kubernetes to actually developers, is this idea of the promise theory. I was talking to Lucas, who is a prominent member of the Kubernetes community, and Lucas explained Kubernetes in the idea of the promise theory. The promise theory in Kubernetes is that once you have a cluster up and running, you give it a task. And the task is not a detailed description of what you want the cluster to do. It's just an intent, a wish. I wish to deploy 10 instances of this application. And Kubernetes, being an eventually consistent system, will eventually get to a point where that wish is realized, right? So if you think about it, it's just a promise theory. It promises you that something will happen. It doesn't guarantee it, because there is so many variables that could make your intent not applicable. But it will eventually deliver on the promise of getting something done, right? Just keep this in the back of your head next time you're talking about Kubernetes with your boss. Kubernetes has a lot of, the slides are kind of funny. Okay, has a lot of primitives for doing a lot of things. Pods, replica sets, nodes, stateful sets, cron jobs, etc., etc. Those are the built-in primitives inside Kubernetes itself. And we continue developing over those. The job and cron job primitive is quite new, and now is becoming a big thing because of the AI ML frenzy, hype, whatever you want to call it. But one thing that is interesting about Kubernetes itself as a project is that the community have been going over a very long, extensive effort to reduce the technical depth, to remove from Kubernetes the thing that Kubernetes itself doesn't have to care about. And this is typically what we refer to as in-tree or out-of-tree code. Essentially, in-tree means it's code that is part of Kubernetes open source. Out-of-tree, it's a plugin. It's something that doesn't belong in Kubernetes. It sits in a different repository. It's not the community's problem. The best example is the last code deprecation that happened very recently, which was removing, this is actually my favorite example of what really developers care about, removing code. 1 million lines of code that was removed. The last deprecation of Google Cloud and VMware code inside Kubernetes itself. This is a screenshot from the pull request that was tweeted by Dims, one of the Kubernetes maintainers. And it was something around the lines that, like, this is my favorite thing to do, just removing code, right? Before I move on, Kubernetes has this very powerful concept which tends to be kind of underlooked. A lot of people think of operators are just a tool. Operators are actually a very powerful programming framework, because you can build your own operator. Anybody can build an operator inside Kubernetes. And you can even build it with, and bear with me for a moment, Java. Right? Some people will be laughing. Yes, you can actually build operators using Java. You don't have to do Go. You can build operators using any code you want, because an operator is, at the end of the day, it's just a pod that runs inside the cluster. And basically it does 3 things. Observe states, differentiate states, act on states when a diff exists, right? Talking of operators, one of my favorite debates to have on the internet is databases. And I'm going to ask the audience a question. Raise your hand if you think databases belong in Kubernetes. Raise your hand if you don't think databases belong to Kubernetes. It's the camp of databases belong to Kubernetes is winning, because there is less of you. So, joke on you. Actually, if you follow what Kelsey says, because let's all admit it, we just pick up what Kelsey says and use it to do a keynote. He basically tweeted this thing, which is, if you think of Kubernetes as a VM, with storage, processing, and I'm paraphrasing here. If you think of Kubernetes, or you think of a pod as a VM with storage, memory, and CPU, you can run anything inside that thing, right? Like, there is nothing that prevents you from just putting a database inside the pod. And these debates about whether databases belong to Kubernetes, or whether such and such workload belong to Kubernetes, all comes from the fact that, again, paraphrasing Kelsey, people think of Kubernetes as an end goal. People deploy Kubernetes with the idea that once we have Kubernetes, our work is done, we go pop up champagne, and then, project is over. That's not the case. Kubernetes is a platform to build other stuff on top of it. So never think of it as the end goal. That's not your final destination. That's just the beginning of a journey where if you are refactoring toward microservices, containers, and running on top of Kubernetes, that's the beginning step. And there is more and more steps coming in the future. So what does the future look like? Max, do you know?
Unfortunately, it's something which I have not obtained yet as a capability, but we can try. We can try to find out what is some part of the future.
The other way around? Yeah.
Well, Kubernetes is still part of the future, right? So, but we really don't know, obviously, for obvious reason. Sometimes technologies drop in and are causing a sudden hype. Who used GenAI, or who's annoyed by GenAI? Thank you. But, I mean, this is a technology, AI in general, which is very old in some way. But GenAI makes it so simple to use that suddenly everyone can use. That's the superpower of this technology. And that's what we always see. As soon as something becomes simple enough to be usable, it's something which can be adapted. Now, we have a few things in the space which we see coming up, which driving innovation. Who has ever heard of the pervasive cloud? I thought so. This is the idea of running or not differentiating anymore between where is my workload running. Because as of today, we differentiate between private cloud and hybrid architecture, public cloud, infrastructure as a service, edge, and whatsoever. Whom of you knows a technology which doesn't care where it is running and what it is running on? Right. Ian?
Is it Kubernetes?
Well, yeah. Obviously, it's one of the technologies under. There's other options. You can also think smaller and containers and whatsoever. But Kubernetes really makes it and puts it on the edge or in any kind of other workload scenarios and really abstracts away all of the things. And if we bring this all together, if we federate different platforms, then we get the pervasive cloud. Right? We don't care anymore where we are running our workload. But as also Abdel said, we need then again also a radical simplification. Because where we make things more simpler and bringing things more together, in the end, it becomes complex again. So we need to put something on top and start our work again from the beginning to make all the next level of abstractions more simpler to use. And yes, all of this maybe needs some AI, because the market is not infinitely flushed with IT engineers. If you look into the German market, we have less and less IT people finishing university or finishing their apprenticeship. And you have more than 150,000 open IT positions, just in Germany. That's an insane number. Put this out through Europe, it's a couple of million open positions. And even so, the market is at the moment a little bit shaky and not super duper stable. We still need the people for the future, because in the next 10, 15 years, or more than half of all the people are going into their pension time. Right? We will see new security concepts coming up. Right? We have a lot of research about quantum computing, and it's still like somewhere cellar in the fridge doing some weird mathematical things. No one understands it. But at some point in time, you can access it. And then we need to introduce new approaches how we can protect our workload and how we can ensure that we still be on an encrypted and good side. And we also believe that in some way, we maybe will see Web3 again. Right? It got in the last years a little bit into this dirty corner with all the NFT scams and people who lost a lot of money in bitcoins and other stuff. But the concept behind it is an abstraction, a distribution of workload. You don't care anymore where it's running. It's just a secured environment, and it ensures that wherever you need your workload, it's directly and immediately accessible in a secure manner. And then we see tons of other things coming up. We see WebAssembly. We see that it's maybe a good companion for the container technology. Maybe it's a replacement in the future. But we see a heavy and strong movement in the market, in the development of all tools around it. And it's maybe a good option to utilize clusters and systems until a 98%, 99% of the CPU. Why we should do this? Well, cloud sustainability. IT is causing at the moment around 2% of the global CO2 footprint. It varies a little bit because of the year time and which data centers we are talking about. And some very old estimations assume it will have until 2025, so next year, almost double this CO2 footprint. But if you take a look into recent reports, how many large data centers are built and needed, well, we will more than double this. There's news that Tesla and SpaceX are building a completely new data center, stuffing it with 50,000 GPUs from NVIDIA, and going to train their AI model. 50,000 is a mini little village or city with more than 50,000 households, right? You can operate a whole village or just as GPUs. Besides that, yes, AI and the engineering we see the homomorphic encryption so that we have a secure end-to-end pipeline of processing data, for example. And we will also see some kind of the great merge or the great connection. Right? We're talking about the federation, bringing systems more and more together, abstracting away again the layer which we have around it. And who has maybe followed up in the recent week, LinkedIn and all the other beautiful social media platforms, you maybe have seen the new Gartner hype cycle for container technologies. And if you take a close look, and yes, I know it's a little bit hard to read, but to get the very sharp picture, you need to pay a lot of money for it. You can see Kubernetes has gone through the hype. We are in the slope of enlightenment. But you can also see there's a few tools and stuff like, for example, FinOps, which is going to peak into the top, which I found strange, because who uses GitOps? Yeah, turn around, almost everyone. I have never seen anyone in the last 1-2 years who's not implementing GitOps. Why it's so late? Right? We can also talk about, for example, KubeVirt to run virtualization with Kubernetes. A lot of enterprises are taking this on to abstract away their complexities. And also with the recent movement on different license changes, where you suddenly cause a lot of costs for hypervisors, it becomes more and more relevant. We see OpenTelemetry in the top. We see already WebAssembly have passed the peak. I mean, the specification of WebAssembly is like ready since a few months, so that was fast. But when I look at it, the only thing which comes to my head is, damn it, we live already in the future because we do all of this every day, all day long, and it's not so much special new things. But why it doesn't feel so special is because we're closing the loop. We're still running the machine. We're building our next abstraction layer on top of what we have built so far with Kubernetes. We built our platforms. We built our now internal developer platforms and focusing on bringing more and more capabilities towards the development, towards the operation, and so on and so forth. So what does it all mean for us in the cloud-native space? Well, I think we will never run out of work. When we are done with implementing Kubernetes, we will have to implement the next platform on top of it. Maybe we run this all with WebAssembly. Maybe we will have everywhere homomorphic encryption. Right? Maybe we will have not one cluster, but the whole organization, the whole IT organization is running in one large cluster. Even that sounds maybe for some people like a nightmare, but you also run all of your IT in one single virtual cluster most of the time. There's no difference. So there's a lot of room of improvement for us and a lot of things which we can do in the future. And the next 2 days is for you to discuss and connect with all the people out there about their ideas, about what they're working on, get some new ideas, and find out how they implement their Kubernetes clusters and bring it onto the next level.
What is sure is that there will always be somebody using admin as a username password. And you can consider this as an idea for an unconference discussion about whether are we moving toward better security with post-quantum encryption, or whether somebody will still write a password on a post-it and put it under their keyboard. With that, we hope you have. Before we go, just a very shameless plug for the podcast. We will keep you posted about what's coming. This is actually what we are aiming to do with our podcast, so please subscribe if you have an opportunity. And with that, I am Abdel.
I'm Max.
Thank you very much. I hope you enjoyed this.
Thanks for being here.